Hello friends, my name is Nikita Sergeev. I had fun working with Matthew and he introduced great idea to implement something similar to hearing system, and I offered to use observer pattern, which is probably the most straightforward one in this case. So there are some triggers which produce event function such as character, bottle, and anything else. So this notification goes to AI manager, which is our subject, and then AI manager notifies all enemies. So my part of work was optimization of existing algorithms, and part of it was to implement a bottle function which was triggering that notification event. So let's look at this. So first I download this bottle, as you already seen that. I created destructible mesh with it. So to use destructible mesh, you have to include these, as we included AI module in C# document in the project. Later, when you reopen Unreal, you can create destructible mesh. So once you create it, you can see similar to this file. When you open it, you can see your mesh. And on the right side, there are different parameters, how your interaction with it can accumulate or not accumulate damage, and what are the parameters to break this mesh. So you can create different levels of its destruction. I don't know how to say that, but it works using Voronoi algorithm. You also can use Houdini to break your bottle or whatever. So I was playing with different parameters, and I was trying to find the best one for a bottle. So it's not that important for the project. We just needed the fact that the bottle breaks. Next, what's the most important is to set up blueprint. So for the bottle, and not just for the bottle, like I created the class component noise notify, which, as I understand later, Matthew used for the player character. We can actually look at this. Yeah, it was also used here. So the main thing of this class is that it has two parameters in on notify function. So particularly this function notifies AI manager, which is a subject, and then we notify our enemies. So how it works? Matthew implemented this function. So he creates AI manager, he takes the reference of AI manager, and he notifies agents there. As I understand, there should be array of, and then notify agents, iterator for all agents. So he does notification because he was working on the behavior tree. So it looks beautiful. How it works from the blueprint. So I've set up blueprint to do this. In case of bottle, there are two events which can produce sound, and I added two variables based on the volume. So the plan was that our agent produce noise at some position, but also has some volume, and based on that volume, there is a radius of agents which can hear or can hear. So some of them would be triggered, some of them not, based on the range from that noise stimuli. So the blueprint of our components of our bottle, and if you look at this, here are two events. First event is fracture. Fracture is relatively straightforward. So we play sounds at the position of bottle break, then we notify our agent with break, we pass this value to volume. So these two functions are implemented by Matthew, as I understand. And for the case of hit, to avoid the case when we hit our bottle multiple times and the sounds overlap itself, we put here a delay of 0.77 seconds to wait. This is particularly the length of that audio clip. This assignment is optimization, and if I select any actor navigation node, you already be able to see that I have connected nodes, but also some value. I don't know what's that. Let's begin. And right now you can see that every node has distance to its connected nodes. Okay, cool. Let's look how it works. If we go to this function, to the class AI manager, first make sure that it's false, it's not ticking, as well as navigation node, because remember that it was true. So this is first optimization. Second optimization, so you can see that in current implementation of A-star algorithm, we calculate the distance every time we go through this loop, so it's not cool. So what's cool probably is to change t-array to t-map. It's one of the solutions, and instead of calculating the distance many times, we can just calculate it once, and we can do it in the not in the constructor, in the begin play, but we can, I think that we can do it in the constructor. Haven't tried that. So we calculate these distances, and that is all. Later in A-star, we just taking the distance from that node to the next one. The problem might appear if you're using nodes of dynamical positions. If it changes over time, probably it wouldn't work. But if you're not changing the position of your node, it's better to use this approach. It's not just distance, the problem that we're calculating something, we're calculating distance. Distance itself is a tough function because it takes square root. And a similar problem happened here, because when we're doing find nearest node and furthest node, we calculate distance just to compare. That is why we can just take distance squared and compare square distance, so without taking square root. It's significant improvement. Okay, what's next? I was trying to solve is, if we look at this, we can change the position of actors, and I think this is beautiful, because when we're doing level design, it's very convenient to adjust these nodes manually, and at the same time we can look at this actor class. It has so many variables, we need just the position of it and the position of child nodes. That is all. So in case of lab of week 6, it was tough for our algorithm to do spawn actor, so it was super inefficient. And what I did, I created an empty class, so you can see that the only difference is that it has f vector location. Here is implementation of it, and in AI manager, like first I have t-array of navigation, of pointers of navigation node, and in AI manager I do populate nodes. Right now here I move all the information from a navigation node to nav node, from actor to not actor, because when our design is not specified, I'll better use this way. But when the design is specified, I already don't need to do this separation, and I'll just use the coordinates. And that's also, I'm creating it with new. And then I was drunk with coffee when I was writing this function, so it basically moves from one dictionary using keys. So it just moves data from a nodes to nodes. Here I just spawn them, here I move the data, and then I'm erasing the dictionary. So here I'm using my nodes and connection nodes of type navigation node. Yep, cool. And you see that it draws normally, and our actor can move towards. So I'm pretty happy with it, and that is all. I think that you somehow learned something new.